Hello everyone. In today's video, we will solve this problem based on the concept of normal distribution. As per the problem, the height of students in a class is modeled by normal distribution and the heights have a mean of 60 inches and a standard deviation of 2.5 inches. And we have to determine the height that is exceeded by 75% of the class. Now I've put the z-score table on the board because we'll need it to solve this problem. Now one important thing we have to understand here is that we have to calculate the height that is exceeded by 75% of the class. That means this is also the height that exceeds 25% of the class. So the height that exceeds that is exceeded by 75% of the class is also the height that exceeds 25% of the class. Now this is a very important concept because the z-score table gives us the probability or area under the curve to the left side of the value we are analyzing. Now, since we are given that the height is exceeded by 75% of the class, so that 75% of the class represents the area under the curve to the right side of the height we want to find. But since the z-score table is only good for the probability or the area under the curve to the left side of that value in the normal distribution, so that's why we are interested in the percentage of class that the height exceeds. And in this case, this height exceeds 25% of the class. So now we have to find the z-score value from this table for that 25% or the 0.25 area under the curve value. So now we'll have to use the z-score table. We have to look for the value 0.25. Now we don't have the exact value 0.25 in this table, but we have these two values here which are very close to 0.25. One of them is slightly higher and the other one slightly lower, and both are in the row negative 0.6. Now the first value, which is slightly above 0.25, is in column 0.07, and the other value, which is slightly below 0.25, is in column 0.08. So that means the z-score associated with the 25% of the class that has a height below the height we want to find, the z-score value for that area under the curve is negative 0.675. So I chose the value between negative 0.67 and negative 0.68 because this is the best approximation for the value that lies between, almost in between these two values in the z-score table. Now we will use this z-score value to calculate the height that is exceeded by 75% of the class. So we'll use the z-score formula. So the z-score formula is x, which is the height we are interested in, minus the mean of height divided by the standard deviation. So this is the mean height and the denominator represents the standard deviation. Now we can sub in the values. So z is equal to negative 0.675 equals x minus, and the given mean is 60 inches and the standard deviation is 2.5. So this is the equation we have to solve to find the height. So the first step is to cross multiply 2.5. So we get negative 0.675 times 2.5 equals x minus 60. Now we can do this calculation. So I got negative 1.6875 equals x minus 60. Now we can continue the calculation on this side. Now since we have to isolate x, we should add 60 to both sides. So by doing that, the 60s on the right side cancel each other out. And now we are left with negative 1.6875 plus 60 equals x. And now we can combine these numbers on the left side. This is the height that we are looking for, that is exceeded by 75% of the class. Now we can round our answer as per the given rounding instruction in the closing statement, and we can also use the given unit. So the closing statement can be the height that is exceeded by 75% of the class is 58.3 inches. So I rounded my answer to 1 decimal place. So I hope you'll find this video useful. So please keep in mind that we are interested in the area under the curve that lies on the left side of the value that we want to analyze, because that's what the z-score table gives us. So since we identified that this height exceeds 25% of the class, so the area under the curve that we want to analyze is 0.25. So we find the z-score value for that area under the curve. In this case, we didn't have exact 0.25 in the table, so we use the approximate value. So if you find this video useful, please share it, like it, and subscribe to my channel. Thank you very much and have a nice day. Bye.